Okay, I did turn it on Tuesday, so you can go and check Screencast-O-Matic and see what you missed. Did anyone go and check that? No, sir. Okay, please do so because that leads us right up to where we are now. So be sure to check Screencast-O-Matic and see the Tuesday's class. This one will be there too. As you see, it's going. So I have several things open. PowerPoint, of course, Screencast-O-Matic, and Zoom. They're all open and operating. And sometimes it sort of slows down my computer. And my pen yesterday was giving me lots of fits. But hopefully we'll be able to manage this. So if there are no more questions, we did example 3 last time. And we're ready to start example 5. The trouble is example 5 is not on the PowerPoint. So I need to go back, and here's where we'll begin and do example 5. So any questions before we get started? Okay. Can everyone see the screen? Just want to make sure of that.
Yes, sir.
You can. Good. All right. Every now and then it will fleck off and you won't be able to see it. Just let me know, and then I know how now to get it back on. Tuesday I probably had difficulties with that, but the Screencast-O-Matic, it was still up, but the Zoom, it wasn't. But Zoom doesn't save the Zoom. The Screencast-O-Matic does. All right, so here's example 5. Sketch the graph of this function. F of x is equal to negative 9/2 x plus 6x squared minus 2x cubed. Okay. Now, what the question said, sketch it. Okay. Now, of course, one way to sketch it would be just start a t-table and plugging in values and go from there. I think you'll find if you try that, that's going to be very long, very involved, and you might be a long time before you get a picture of what the function really looks like. So that's not the way to go on this. The way to do is to use everything that we put in our toolbox so far and see if we can figure out how to sketch it. What would be your suggestion of what to do first? Any ideas? Is that somebody coming in?
No, sir.
Okay. All right. What would be your idea of what to do first? What looks like it's wrong with that function? How would you make it look better? Any ideas? Second? Yes, put it in the what we call standard form order. Okay, and what would that be? Okay, no. Here's the highest order. Negative 2x cubed plus 6x squared minus 9/2 x. Perfect. Okay. What would be your next step?
Turn everything into a fraction.
Okay, a little louder.
I said turn everything into a fraction.
Okay. I sort of like what you're saying there, but I don't know exactly how you meant that. What I don't like about it is the fact that you do have a fraction in it, right? Another thing I don't like is the fact that you have a minus sign as a leading term. I don't care for that too much. Well, wait, I'm sorry. Let's say before we do that, remember what our goal is here? Sketch the graph. So let's go on and do the graph here, okay? I don't know if I'm putting it in the right place until we do more. So I'm going to tick off a few points. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. Positive 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. Okay. There's a few points. Now, first thing I'm going to ask myself, since I'm sketching is the whole purpose here, what was the first thing we did about higher order functions? Do you remember? It was called the end behavior. What is this function doing for very large x's positive and very large x's negative? Anyone remember this? I can't remember if this is one we did in class or one that I did when nobody was on the system. Does anyone recall? End behavior? The book called it the leading coefficient test, but I called it the leading term test. So in case some of you weren't here, then let me go over that. Look at the leading term. That's it. Now, why do we focus on the leading term? Well, that has the highest degree of x, and when you get very large, and this only works for very large x's, when you get very large x's positively or very large x's negatively, this term dominates. It takes over and ignores everything else, okay? Because you're raising that. Let's just take a value for x. Doesn't have to be very big. 10, okay? What's 10 cubed? Anyone know? 1,000. What's 10 squared? 100, and 10 is just 10. Well, guess what? 1,000 is going to dominate. Doesn't matter what that middle term is doing. That 1,000 is going to take over, okay? And if you don't think that's enough, go up to 100. 100 cubed is 1,000,000. 100 squared is only 10,000, only 10,000. But that's nothing compared to 1,000,000. And then 100 is just 100. So yeah, for large x's, either large negative or large positive, this term is going to dominate. Understood? Okay. Now, the two things we look at for leading terms. Anyone remember this? Okay, does anyone remember?
No, sir.
Okay. The one thing is the even or oddness of the exponent. Okay? Does this ring a bell with anybody? No. Ah, very good. Yeah. The odd exponents means going one way it's going up, the other way it's going down. Or going one way it's going down, the other way it's going up. If that exponent is odd, they're going in opposite directions. If it was even, they're going up and up or down and down, okay, in the end behavior. So, which way are they going depends on the sign of the leading coefficient, okay? And again, here is where I like to take a value like 10. 10 cubed, what do we say it was?
100.
No, 10 cubed is 1,000. Okay, so 10 is way out here somewhere. When you cube it, it's 1,000. But then when you multiply it by -2, it becomes -2,000. That's going way south. For a large positive value of x, you get going very large negative in y. Does that make sense? Okay. I see a Galaxy S10 show up. Who is that? Someone new entered the class?
Zach.
Who is it?
Zach.
Zach. Oh, that's you, Zach. Okay. I already marked you present. Okay. All right. Now, let's take a negative, such as -10. What's -10 cubed? -1,000. But then when you multiply that by -2, what does it become? +2,000. So when you get very large negative numbers, they're going to be going up really, really fast. All right. That takes care of the first thing. That's our end behavior. Now, we're not going to use it for a while, but we will use it later. Okay? Now, let's go back to our earlier question. What's the ugliest thing about this function? I think someone mentioned the fractional form, didn't you?
Yes, sir.
Okay. So what we'd love to do, and I also don't like that minus sign in front. So but we need it there to know what our end behavior is. Now that we've determined that, let's factor out both the fraction and the minus sign and any other common factors. Are there any common factors in here? X's, exactly. So let's factor out from this term here, this expression here, minus x over 2, or minus 1/2 x. Maybe let me write it that way. That might be easier to wrap your heads around. Okay? Minus 1/2 x. Okay. Now, what we're doing when we're factoring is really dividing. Okay? And if you divide -2 divided by -1/2, I'm just doing the coefficients now. Okay? What is that going to give you? How do you divide fractional forms? Oh, this goes way back, doesn't it?
You say what?
How do you divide a fractional form? You see what I've written there?
Yes.
Okay, how do you divide that? Okay, put a 1 here. And what do you say? Yes. Do the -2 over 1. You're absolutely right. Then change the division to a multiplication. But what do you do? Flip. That'll be now a -2 over 1. It was -1 over 2. Now it's -2 over 1. When you multiply two minuses, what do you get? A positive. And you multiply 2 times 2, you get 4. So now this becomes 4. And you factored out 1x, so that gives you x squared. See what we did? Okay. Let's move to the next one. We're going to take a positive 6. I'll go on and put it over 1 and divide it by -1/2. Anyone want to make a guess of what that will become? Negative, you're right. 12, -12. Okay, so that's going to be a -12, and we factored out an x, so that leaves a little x remaining. All right, then that last one, and this is the whole reason we did it. I'm going to erase these because I'm running out of room. You okay with that?
Okay, so what we doing right here, we just factoring out 6 and
No, we're factoring out the -1/2 x. And that left us, the first term became a 4x squared. The second term became a -12x. Is that what you're asking? Okay. When you factor out, what you're doing is dividing. Let's try it with the next one. We started with a -9/2, and we're dividing that by -1/2. Any guess of what that's going to become? I heard someone say something, but I couldn't make it out.
I said no, sir.
Oh, I see. Okay. Well, what would be the next step? I'll start it off -9/2. That doesn't change. Yeah, times and flip. You're absolutely right. -2 over 1. Now, I actually remember some junior high teacher or something like that, maybe even elementary, when she was teaching us this, she said, picture this as a bear walking over a log. There's his 2 paws and there's his log. But he gets his legs crossed and falls over and flips it over. That's how she told us to remember invert and multiply. Anyway. The 2's will cancel out now, and what are you left with? And that's not a 9, a plus 9. So that's what we have here. Now, let's step back for a moment and make sure what we just did is right. Okay? If what we just did is right, then when we multiply this through, distribute that through, you should come out with exactly what you had to begin with. Okay? Well, let's see. Negative 1/2 of 4 is negative 2, right? And x times x squared is x cubed. Yeah, that works. Negative 1/2 of negative 12 is it's positive 6, and x times x is x squared. That worked. Negative 1/2 times 9 is negative 9. Oh, yeah, negative 9/2 times x. Perfect. That is it. Okay? Now, so this function here is the same as that one, is the same as that one. So now let's try to analyze it. Okay? The first question is, can we factor this any further? How would you choose to do it? Anyone want to make a guess? Getting close to my camera there, wasn't I? Just this part in parentheses. How are we going to factor it? You want to make a guess? What's one possible factorization for 4x squared? What's the first thing that comes to mind? Factor 4x squared. 2x times 2x. Let's try it. 2x times 2x. Make sense? Now something just happened up top. Did someone else join the class? Who did? Kwame? All right, welcome back. I know you've been quarantined, haven't you? What's that? What's that? Oh, not everybody knew that, huh? I'm sorry. Well, no, I mean, you're well, aren't you? Yeah, self-quarantine. That's what I meant. But and you're well, right? Excellent. That means you were exposed, but you didn't catch anything. Excellent. But you say you've been self-quarantined since you got back, right? Yeah. Okay, so you didn't expose anybody. Correct. Excellent. That's why they did it, and I'm glad you did that. Okay. Yes, sir. All right. But welcome back. Now, has anyone else joined the class? I only have 4 so far. I have, who is that? Did someone say something? Okay. Wait, I see that there's 11 participants now. So Cameron's here? Welcome, Cameron. Let's see, I'm in the right guy. Okay, and Trina is here? Trinity's here? Yeah. Gotcha. Who else? I see an iPhone with a fan on top. Pink wall. Who is that? Cameron, okay. But I see 11 participants. Who is? Jalen Crawford? Is that what you said? Yes. Oh, excellent. Welcome. Okay. Jalen, I do have a question for you. I hate to be asking these things there, but it's the only way I can find out. Did you ever get a copy of the first test? I don't think you started it, did you? Jalen? Okay. I think I may have lost you. All right. I want to come take my first test when we allowed back in school. Okay. You know, okay. I might as well get this said now. Even though they say we're coming back to school, what, that first Monday in April?
Yes.
I would not bank on it because my wife's an infectious disease epidemiologist. She studies diseases, okay? She's been tracking this from, the website, that famous hospital in Baltimore, I think it is, or Minneapolis or somewhere. And the numbers are still going up. Now, people doing smart things like self-quarantining and stuff like that, that's helped slow it, but it's not over. It's nowhere close to being over. So if we are back in the second week in April, I will be shocked. And what's even worse, because of my health situation, they may not even want me to come back on campus at all. I'll still be teaching. So we may still be doing this till the end of the term. So therefore, I've got to get you your test. And what I'm going to do is scan the test and send it to those people who never got it. I think there were 3 of you. Okay? Those others who didn't finish it, I'm going to mail them to you, but I'll need addresses. But if you don't want to give your address on this, I don't blame you. I'll get it from the school or something. So I'm going to try to mail those hopefully tomorrow. Okay? Now here's the other changes that are going to happen. Normally we'd be having a quiz at the end of section 2.3. That's the next section. That's going to become a test. In fact, your first quiz will become a test. Not going to be any more quizzes because everything's take home. So I'm going to give smaller tests more frequently because everybody's going to have to be taking them at home. Okay? So we're going to do that for the rest of the term because I don't think we're coming back on campus. We're going to continue to have classes, but if we are back on campus, I will be absolutely shocked because the numbers are still going up, and the only reason they may be slowing now is because schools are closed, and my wife said that University of Alabama, UAB, have said online for the rest of the term. So I think Lawson's going to do the same thing, okay? They just haven't made up their mind yet, but I think we got to do it. And it may be with my health, I've got to do it. So what I'm going to say is don't wait and say I'm going to do something when we get back on campus. I don't think we're coming back to campus, okay? I don't know that for fact. So what I'm going to do is email you that test. Now, you did get the first quiz, didn't you? I'm still talking to Jalen. Did you, Jalen?
Yes.
You did. You got the first quiz. You need to get that to me. I'm supposed to have it before. Now, it's going to become a test now. So do well on that and then do what is listed as the first test. It's now going to be the second test. So I'm going to send that to you. Like I said, I'm going to try to mail it tomorrow. I don't have any time today because I'm in class until 5:45 this evening. And I'm not going to have time to mail them before then. Okay? All right. Now, has anyone else joined the class? I see 12 participants now, and I don't have but 1, 2, 3, 4, 5, 6, 7. Quamisha. Yeah, Smiley, got you. Okay. Who else? Who else? I can't hear. Okay. You have to speak up. I can't hear. One more time.
Can you call out the people that you do have?
Okay. Oh, I got it. Zach, Jalen, Keelan, Kaya, Trinity, Kwame. I got you. Cormisha and Cameron. Now, you want me to call the rest of the roll and you answer? Shakita. Okay, let me find you. Okay. Give me your last name.
Rogers.
Oh, got it. Okay, Sean.
Yes.
Oh, okay. I couldn't understand. There you are. Okay. Anybody else? Yeah, I see Sean's name now. See, if you say something, your name pops up. So say something.
Oh,
If,
okay.
yeah, anyone who you didn't hear me call your name.
Doctor,
Who's that?
Nigeria.
Oh, Nideria's here. Good. Okay, others? Okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't see how many are in the class anymore, so anyone whose name you didn't hear me call.
What about the essay? How can we get that to you?
Okay, everything that you send to me, there's a couple ways you can do it. Probably the best way is to scan it, or you don't have to scan it even. If you got it in Word, just attach it to an email and send it to me.
Okay.
Okay? Same thing when you get a quiz or a test. They're all going to be tests now, even if it says quiz. When you finish it, scan it to me, or either, yeah, the quizzes and tests you're going to have to scan because I won't see your answer otherwise. So scan it and send it back to me. But your paper, if it's in Word or even Word Perfect, I can take Word Perfect. No one uses that anymore. But if you do that, I can just send it to me. I'll print it, I'll grade it, and I'll put the grades on Blackboard.
Now, I don't use my Lawson email, so I would at Yahoo.
Okay, I will receive if you got my email, that'll be fine. Now, you're saying you can't receive Lawson's email?
Yes, as far as you send them to me.
Okay, now who is talking now? Sean?
Tankita, I'm Sean.
Okay, yeah, if you send me things okay, if I send you anything through email, I've got to use your Yahoo account. Is that what you said?
Yes.
Okay. I probably don't have it, but I don't want you to put it out here now if you don't want to. I can get it from someone at the college. So I'll try to get that if I need to. I don't think I'm going to need...
I can put it out here because it's just my first name at yahoo.com.
Okay.
I'll put it,
Okay. Why don't you email it to me, okay? Why don't you do that? Not right, I mean, you can do it right now. I won't see the email until later.
Okay.
Okay, but yeah, email me just email me a message and I'll return. But I don't think I'm going to need to be sending you anything. But if I do, I'll do that then. Okay?
Okay.
All right. Now, it still seems like I'm missing one person, but if you don't say something, I'm probably not going to be able to get you on the roll. So please speak up at some point. All right. Now, where we left off, we were trying to factor. This is example 5 on page 129 in section 2.2. We've gotten it this far, and you'll have to go back to Screencast-O-Mat or to YouTube video and pick up the first part of this. But what we're trying to do is factor this trinomial here. And someone got us started with saying 4x squared can factor as 2x times 2x. Now, that's not the only factor, but it is. Now, I still say that I've got 11 participants. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm the 11th. So I think we got everybody. All right. Where do we look next to see how to factor this?
The -12.
Okay. Yeah, you sort of do, but you look at the positive 9 first. The plus sign there says that these two signs have to be the same. Okay? And then you look at the -12 to see they both have to be negative. Okay? The next step, come up with a possible factorization for 9. 3 times 3. Now, we don't know if that works, but we're going to try it. Let's do our foiling. 2x times 2x is 4x squared. We knew that worked. And then let's do the outer. That's going to be 2x times -3 is? 2x times -3 is? -6x. And then the innards, -3 times 2x is? Negative 6x, and negative 6x plus negative 6x is negative 12x. That works. And then you do the last, and that's negative 3 times negative 3 is plus 9. And that works. So yeah, you factored it right. So that's why you got a smiley face up there. You see it? Good. All right. Now, you have now factored that. I'm going to write it over here. This is going to be negative 1/2 x, okay, times 2x minus 3 times 2x minus 3. Okay, now we have to determine our zeros. That's why we factored, to determine the zeros. Where this function is going to cross the x-axis. Those are going to be where y is equal to 0. So you set it equal to 0, and what do you get? Set this equal to 0, and what do you get? Let's do the first one.
You can combine those 2x minus 3.
Okay. Well, I'd say separate them, not combine them. They're already combined. So this, oh, you mean the 2x minus 3s? Oh, yeah, you could do that and write that as 2x minus 3 squared. Is that what you meant?
Yeah.
I thought that's what you meant. Okay, yeah. So, yes, that works too. Okay? So, let's first set this one equal to 0. What does that give you x is equal to? Actually pretty easy.
What's the question? I'm sorry.
Okay. Negative 1/2. We took this factor here and set it equal to 0. What we have is a series of 3 things multiplied together equals 0. That means one of them's got to be 0, right?
Right.
Okay. So let's do the first one. Negative 1/2 x equals 0. What would that give you as a value for x? It's pretty easy. Negative 1/2 x is equal to 0. Solve that for x. Isolate the x.
Oh, 1/2. Wait, no.
How do you do that? It's pretty easy. Or just think through it. Negative 1/2 times something has to be 0. What would that x have to be? 0. It has to be 0. How you can do it mathematically is multiply both sides by negative 2, right? And now the 2 cancels here. The minuses cancel. You have x is equal to 0 times negative 2, though, is 0. So x equals 0. So I'm going to put that point right here. 0 for x, 0 for y. 0, 0. That's one of the intercepts. Okay? Let's go to the next one. 2x minus 3. Set that one equal to 0. Now, y'all can do that one, can't you? How would you solve for x? Add 3 to both sides. Got it? And what?
Divide both sides by 2.
Okay, and that gives you x is equal to 3/2. Right?
Yeah.
All right. 3/2 is right over here, right in between 1 and 2. 1 1/2, 3/2. But you see, this one's the same thing. So that's a double root. There's 2 of them at that same place. Okay? Now, I contend these are your only zeros for this function. So I contend we know exactly where this function is going. It's starting over here from way up high. Okay? And then it's coming down and has to pass through 0. Now, because that's a single root, it passes through 0 without stopping. Just goes right through. But then it turns around and comes back up to this 0. But because this is a double root, because it's 2x minus 3 squared, it doesn't cross the x-axis. It just kisses it and turns around and goes back down again. Okay? There's the function right there. Because you see the end behavior is down here and up here. So there's the function. Okay? Now, I probably don't have it in the right places, how you can determine that, and you really don't need to, but the book likes you to do this. Let's pick a few what they call test points, okay? And one test point might be this one, x equal -1. Another test point might be this one, x equal +1, and the final test point, x equal 2. Those are the easiest ones to do. They're the smallest numbers. So let's pick them, and we can either put it in the original function or one of the other forms. I think I'd just as soon put it in this form. No, maybe, I don't know. Original form may be just as good. So let's plug in a -1. F of -1. That would be minus 9/2 times what you put there. That's what your x is, right? X equals -1. -1. You see? Okay. Plus 6 times what you plug in for x. Anybody with me?
Yeah.
What do you plug in for x? -1 squared. Minus 2 times what? -1 cubed. Okay, I'm going to have some more room here, so I'm going to erase some stuff. It's just stuff that we were playing around with, getting our other answers. So let's get some of this erased here. Okay, and maybe we can see what we're doing better. Okay, so -9/2 times -1 is going to be what? +9/2. Perfect. Okay, now -1 squared is going to be what? +1, so this will be a +6. Agreed? Okay, and then the next one, -1 cubed, is going to be -1 multiplied by a -2 is going to be a +2. Agreed? Okay, well, you know, I don't care what the value is too much. I just want to know what the sign is. That's really negative. That's 8, and that's 4.5. That's 12.5. So somewhere up here, 1, 2, 3, 4, 5, 6, somewhere up here, we're way up there, off scale. So that one's really going north quickly. Doesn't even get to -1 on this graph. Okay? So we've gotten that one. That was, what did I say, 12.5? That was your y value when x equals -1. All right? Now, just because I don't have much room, I'm going to be really lazy here, and I'm going to change this -1 to a +1. Okay, because that's our next test point, isn't it? Okay, so we'll erase these and see what we get there. Okay. Negative, oh, I forgot to change this one. Well, I know what I could have done. Okay. I could have just made it a plus sign. Okay. So, -9/2 times 1 is -9/2, right? And what's 1 squared? 1. And 1 times 6 is 6. And then 1 cubed is 1. -2 times 1 is -2. So this is -4.5, right? This is -2, so those add to be -6.5, and there's a +6, so this goes down to -1/2. You know, I wasn't too far off there. A little bit off, but not bad. Something like that. Okay, we know the zero's there. Let's try our 2 now. That's our last test point. So I'm going to go up here and erase again. I'll remember to erase that one this time, and that one, and that one, and that one. Okay, and I will erase this mess, and that mess, and that mess, and that mess, and that mess. Okay, Now this time we're going to plug in a 2. 2 here, 2 there, 2 there, and 2 there. Everywhere you saw an X, you put in a 2. And what's negative 9 times 9 halves times 2? Negative 9. You got it. And what's 2 squared? Say again? 4 times 6 is 24. Okay. And what's 2 cubed? 8 times negative 2 is negative 16. Perfect. Let's add your negatives together, and what do you get? Negative 25 minus 25 plus 24 is minus 1. Hey, look at that. I was almost right on top of that one. When x equal 2, your y or your f of x is minus 1. Yep, there's your function. Somewhere coming from way up there, coming down, curving around to this value right here, then bumping back down and going there. There we graphed the function. And that wasn't too bad, was it? Several steps, but how do you eat a 5,000-pound elephant? One bite at a time. So just take it one step at a time, go through the problem this way. Now if you look in your book, you'll see their picture. This is on page 129. They set it up in a table and do that kind of stuff, and you can do that. Look at what they did. They chose the representative x values as minus 1/2 and positive 1/2. I don't want to do that and square them and cube them. That's a mess. I liked ours of minus 1, plus 1, and plus 2. They were much easier to do. But you see, all you're really interested in is what the sign is. Positive, negative, negative. And that's what we got as well. Okay, guess what, folks? There's a checkpoint at the bottom. Try to do that checkpoint as soon as we get through class, unless you have another class coming right up. All right, any questions on that one? None? All right, let's go on. Oh, wait. No, yeah, this is example 3. We did that last time. You'll have to check. That's example 3. That's after example 3. We already did that one. And that's where they talk about the test intervals. We just did that. All right. Now we're ready for, on page 130, intermediate value theorem. All right. Sounds like a really complicated issue, but it's really not. Okay? Sorry. The intermediate value theorem implies, now, y'all probably can't read that, can you? And that, you can. You don't see the pictures? My picture's not in your way, and Kaya's picture's not in the way, and Cameron's name's not in the way? Oh, okay. Well, you can read it. I won't mess with it then. I thought y'all couldn't see that either. The intermediate value theorem implies that if you know 2 points, x equal a, and of course y would be f of a then, right? Because y is always, what's y always? F of x. So if x is a, y is f of a. And if x is b, y is f of b. Well, here's a, x equal a, and here's f of a. Okay? And here's b right here, and there's f of b right there. So this point, that point. Okay? So if you have 2 points on the graph of a polynomial function, as long as f of a and f of b are not the same. F of a is here, f of b is there. Yeah, they're not the same. If they were the same, intermediate value theorem doesn't tell you anything. But if they're not the same, then for any number d that's in between f of a and f of b, if d is in between there, there's got to be some other number c that f of c is going to equal that d. That's what the intermediate value says. And there's 2 reasons this is true, or they actually go together. And here's the reason. Polynomial functions, that's what we're dealing with, polynomial functions, are always 2 features. Does anyone remember what they are? smooth and continuous. Smooth and continuous. And really the smooth part isn't important here, it's the continuous part. Because if you're going from here to here and you can't pick up your pen, then for any value in between there, there's got to be a value down here that makes that true. Okay? Now, admittedly, there may be more than one. In this case, there's only one, but this function here could have been doing this. Okay? That would still be a polynomial function, a really ugly one. It would have had 4 values in between. That's okay. That's fine. But there's at least one. There's always going to be at least one. That's the intermediate value theorem. And here's how it's stated. And again, y'all can read all that. It's fine. Let A and B be any real numbers such that A is less than B. We just want A to be less than B. If f is a polynomial function such that f of A is not equal to f of B, then in the interval from A to B, A being less than B, f takes on every value in between f of A and f of B. And we saw that here. Every value in between f of A and f of B, there is some value that gets you there. Okay? That's what it tells you. Does that make sense?
Yes.
All right. Good deal. Intermediate value theorem. Now, all right, they're going to talk about this function here, and then they're going to do it later, so let's just go on and do it. What's that? Okay, did someone just join the class? Who is this? Okay. Did someone just join the class, or is that someone just yelling? Okay. Am I hearing someone talk to Miss Rogers? Is that what I'm hearing? Okay. Did anyone else join the class? What's that?
So what? Can you put yourself on mute? Because we can hear all of that. Oh, you can hear me? Yes.
Yeah.
I'm so sorry.
Okay. Okay.
Did y'all hear like my whole conversation? Yep.
Okay.
Did you hear me, Mr. Fowler?
Yes, I am hearing you. I'm hearing everything that goes into your microphone. All right.
See, I could barely hear.
Oh, you can? I'm sorry. Because do other people think I'm loud or soft? I thought I was pretty loud. I heard myself last night. I said, whoa, I'm talking way too loud. If you have a lot of noise around you, you can mute yourself. I don't want to mute you because then I won't hear you when you're trying to talk. But you can mute yourself, I think. And then, if you want to talk, be sure you take the mute off. Okay? All right.
Okay, I'm off.
Okay. Bye-bye. All right. So, this is the bottom half of page 131. Here's a function. F of x is equal to x cubed plus x squared plus 1. Okay? Now, mine is broken off there, but it says it's negative when x is equal to minus 2. Well, let's see if that's true. F of minus 2 would be what? Help me out here. Right? Tell me what you do to check it. Everywhere you see an x, you put in a minus 2. So this would be negative 2 to the third power plus negative 2 to the second power plus 1. What's negative 2 to the third power? Negative 2 to the third power. Did anyone say it?
Is it -8?
Negative 8. You're absolutely right. Negative 8. And what's negative 2 squared?
4.
Positive 4. Okay. And what's and then plus 1. Well, negative 8 plus 5 is negative 3. So they're right. This function is negative when x is equal to minus 2. How about when x is equal to minus 1? F of minus 1 would be what? Negative 1 cubed plus negative 1 squared plus 1. And what's negative 1 cubed? Negative 1. What's negative 1 squared? Say again? Plus 1 plus 1. Okay? And what does that give you? 1 plus 1 is 2, minus 1 is 1. These two add to 0, you're just left with a 1. So, this function is positive when x is equal to minus 1. So what does that tell you? It means that every value in between minus 3 and 1, you can find the value for. Minus 3 is down here, plus 1's up here, so you can find a value, including your 0. So if you can find two functional values, one positive, one negative, you know there's got to be a 0 in between, because polynomial functions are continuous. You can't have any breaks. You've got to cross that x-axis somewhere. So you know it's there, we just don't know where it is, okay? And that's going to be the next problem. You know there is a value, a real 0, somewhere in between x equal negative 2 and x equal negative 1. Somewhere in there, there's got to be a 0. And that's what the next example is going to do, is help teach us how to look for it. By continuing this line of reasoning, you can approximate any real zeros of a polynomial function to the desired accuracy, and the concept is demonstrated in example 5 or 6 that we're going to do next. Okay? All right. Use the intermediate value fit theorem to approximate the real zero of that. Now we already know two values, don't we? F of negative 2, wasn't that negative 3? And we also know that F of negative 1 was equal to 1. Say again? Okay. Now, because 1 is closer to 0 than negative 3 is, well, no, just let's pick a value x in between negative 2 and negative 1. What would be a good one? Between negative 1 and negative 2. Negative 1.5, is that what you said? Say yes. Oh yeah, it sounds like a good choice. Okay, so let's go up here and do F. Pull out your calculators, folks. Negative 1.5. And that's going to be negative 1. Now, do y'all prefer to do fractions? We can do fractions if you want to. Hey, she's got a calculator. Good deal, Kaya. You want to do fractions or decimals? With calculators, decimals are easier. If you're doing it in your head, fractions might be a little easier. Yeah, she brought a calculator. She's prepared for her class, isn't she? All right. So this is going to be a negative 1.5 cubed, you finish it, minus a negative 1.5 squared plus 1. I'll finish that, okay. What's negative 1.5 cubed? Kaya's got the calculator, or anyone else who has one will work. I know it's going to be negative 1.5 cubed. going to be maybe about 2 point or 3 point something. Say again? I can't hear. A little louder.
-3.75.
3.75. Okay. Just, I have to watch. I just bumped my cord. I want to make sure it didn't unplug it because my connection isn't good. I'm just going to wait just a second here. Okay. $3.375, isn't it?
Yes, sir.
Okay, I didn't hear. I thought that sounded like too big a number. 3.375. Got it. Okay. Minus, I think I know what negative 1.5 cubed squared is. I think that's 2.25, isn't it?
Yes, sir.
Okay. Plus 1. Okay. So that's going to be negative 3.375 minus a 2.25 plus 1. That's going to be, my calculator did it wrong. I don't know what's going on here. That's a negative number, right?
Yeah, I got -4.625.
There's something wrong with that picture. This had better be something in between 1 and negative 3. And why is that not the case? Let me do that. 1.5 cubed. We're going to negate it. Minus 2.25 was right, wasn't it?
Yes, sir.
Yeah. I've done something wrong and I can't figure out what it is. Oh, I know what it is. They're doing a different problem. Okay. Sorry about that. I thought they were doing the same one we did before. They didn't. They switched it up on me. So let's erase all that. The one we did had a plus in here, and this one has a minus. So we have to find our starting values again. That's where I was wrong. Sorry about that. Okay, let's back up here. Let's try the easiest x. What would that be? What's the easiest x to do? Even easier. 0. What would that be? 1. Okay. I like your choice of 1, so let's do f of 1. Anyone want to guess what that is? That's equal to 1 minus 1 plus 1. That's also 1. Ooh, okay. Let's do a negative. Let's do f of negative 1. Okay? And that would be a minus 1 minus 1 plus 1. That's equal to negative 1. Okay, negative 2 plus 1. All right, those are be the ones that we're going to use. I'm sorry, I wasn't paying attention to the last one. Okay. Now we did f of 1 is equal to 1, and f of minus 1 is equal to minus 1. Okay. So that tells us our 0 has to be somewhere in between, negative 1 and 1, right? Well, wait a minute. Let's not use 1, let's use 0. That's even closer. That's also 1, right? There, I'll just make it a 0 that way. F of 0 is 1. Remember we did that? And f of negative 1 was negative 1. So it's somewhere in between negative 1 and 0. Okay? What's a good thing to choose in between that? Between 0 and negative 1. Negative 1/2. Did someone say that? Okay, negative 1/2. You want to use it in fraction form or decimal? Decimal? Okay, then we'll leave this alone. We'll do 0.5. Okay? Now let's come up here and do our math up here. Okay, that's what we were doing before. Okay, f of negative 0.5. That will be negative 0.125. Is that right? Someone with a calculator. I believe that's right. And then we have a minus a 0.25, right? And then we have a plus 1. Okay, if I add those three together, I think I get a point, is it 7? No. 6. I'm not doing, my brain's not working well this morning. That's 375. So that's 625, isn't it? Positive 0.625. Did I do that right? Okay, good. Oh, we got 2 more people in the class. Who just came in? Who? I can't hear you.
That was me. They didn't say nothing. That was.
Yeah, but I saw 2 more people showed up. Who are they? Somebody who just came in. Let me know your name. Anybody? Okay, I can't mark you present if I don't know your name. Okay? So please let me know. Say something and your name should pop up here. Okay. So here we've got at negative 0.5, we're at positive 0.625. Well, now I know that the 0 has to be between those two. So give me a number in between negative 1/2 and negative 1.
I have a question.
Yes.
So,
Lexus?
no, this is Trinity.
Okay, Lexus just showed up. Let me mark her present. Is this Lexus Simmons?
Yes.
Okay, welcome to the class.
I've been here.
Oh, you have? All right, well, your name just showed up. All right. Okay, Trinity, what was your question?
So, what exactly, you keep saying our 0 falls in between like these digits and these values. So what's telling us?
Okay, what you're looking for is a 0 of this function. That's a f or y is equal to 0, right? And we know the f of negative 0.5 is a positive number. F of negative 1 is a negative number. So there has to be a 0 in between those two. Okay? We just don't know what it is. So pick a value in between those two. Negative what? 0.75? Would that work? Isn't that in between 0.5? Or we could make it easier and just make it either, let's just make it 0.7. Okay? That'll be easier to put on the calculator, won't it? Negative 0.7. So what we'll do is come up here and do a negative 0.7. And if y'all got calculators, you can just tell me the answer here, and I don't have to write everything down, but I'll write it if you want me to. Negative 0.7, that would be negative 0.7 cubed minus a negative 0.7 squared plus 1. Negative 0.7 cubed.
That's negative
Okay? You'll have to say it a little bit louder.
Negative 0.343.
Okay, that's the answer or just that one part?
That's that cube part.
The negative 0.7 cubed?
Yeah.
Okay, then do a minus a negative 0.7 squared, which would be a negative 0.49 plus 1. So what did you just say that first one was? Negative 0.3 what? 43. Then you have a minus 0.49 plus 1. All right? What do those add to?
167.
Say again?
0.167.
167. You see, we're getting closer and closer to a 0. Well, now we know it's in between these two. So let's try the next one to be negative 0.8. You see, it's in between those two. If you got your calculator set up, you can just plug that in up here. Alpha of negative 0.8 will be negative 0.8 cubed minus a negative 0.8 squared plus 1. Let's say 0.8 negated cubed minus 0.64 plus 1. Oh, that's a negative number that time, isn't it? Negative 0.152. Did y'all get that?
Yeah.
Good. So now we know it's in between these two, right? We can keep doing. We might try negative 0.75 then and see if that works. Negative 0.75 cubed, negative 0.752 minus 0.75 squared plus 1. Whoa, we got really close there. Alpha of negative 0.75 is 0.015625. Y'all get that? Something like that? Well, that's positive. So now we know it's in between these two numbers. Okay? And you can keep going until you get as close to 0 as you want to get. I'd say negative 0.75 is close enough for me. Okay, did any other students enter the class? I just saw something pop down. Okay, if I haven't heard your name yet, you got it. So let's see what the book gave. They got negative 0.755. Yep, that's probably what I would have tried next. You're awfully close to 0 by then. Okay? So, they also show you on the side there how to do it using a graphing calculator. And if any of you have a graphing calculator, you can follow the directions they give you there for that. All right, there is a checkpoint. Good idea to do the checkpoint after class. But that finishes section 2.2. Okay? And we got 3 minutes, so let's see if we can get the vocabulary done. The graph of a polynomial function is blank, which means it has no breaks, no holes, no gaps. What's the word for that? I've used it several times today.
Continuous.
Continuous, excellent. Number 2, the blank, blank, blank is used to determine the left-hand and right-hand behavior of the graph of a polynomial function. We use that back there on that first one. Now the book actually calls it, if you turn back one page on that summarize at the bottom of the previous page, page 131, number 2 under that summarize, they call it the leading coefficient test. I call it the leading term test. That's a better descriptor than coefficient. So that's the blank, blank, blank there. Number 3, a polynomial function of degree n has at most how many real zeros? Okay. That one you're going to have to go a little bit further back. Anyone remember that? That will be goodness gracious, I can't see it. I know it's in here. Oh yeah, there it is. Top of page 127. There's a number 1 and a number 2. It's number 1. A function of degree n has at most n real zeros. Now it may not have n, but that's the most it can have. Okay? And at most, this is the second part of number 3, at most how many turning points? 1 less, n minus 1. So if it's degree, give me a number, any number n. How many? 4? Is that what you said? Okay. If the polynomial of degree 4, it's going to have at most 4 zeros, and at most 3 turning points. Okay? Does that make sense? All right. Number 4. When x is equal to a is a 0 of the polynomial function f, the following 3 statements are also true. X equal a is a blank of the polynomial equation f of x equals 0. And if you want to know these are also on page 127 under that first block at the top half of the page. Real zero is a polynomial function. The number 1 was the one they gave you, and then 2, 3, and 4 are the next 3. X equal a is a solution of the polynomial equation. You could also say root would be another word for it. Okay? And then the B part says blank is a factor of the polynomial f of x. If x equal a is a 0 or a solution or a root, then x minus a would be a factor. We do that all the time. If we factor a polynomial and get x minus a is equal to 0, x equal a is a root, is a solution, right? And then number C, a0 is an, or a, well they say an, x-intercept of the graph. And that's what we were doing when we plotted our functions. When we found those solutions, you knew those were the x-intercepts. Okay? Number 5. When a real zero, x equal a, of a polynomial function, f, is of even multiplicity. Now we had one like this when we had, what was that? 2x minus 3 squared. Remember when we had that? Even multiplicity, the graph of f does what at the x-axis? At x equal a. Hint, it doesn't cross, it just touches, but goes back in the same direction. Okay? Touches the x-axis. When it is of odd multiplicity, even including 1, but usually they count 3 or higher, the graph of f, if it doesn't just cross it, if it doesn't just touch, it crosses the x-axis, x equal a. A factor, x minus a raised to the kth power, when k is greater than 1, yields a blank blank x equal a of blank k. Whoa. Anyone going to make a guess at that one? Okay, what you have to do is go back to that page 127. That's a rich, rich page there. Very bottom of the page, repeated zeros. And that first line under repeated zeros says it. A factor x minus a raised to the kth power when k is greater than 1 yields a blank blank repeated 0 x equal a of blank k, multiplicity k. Have y'all got your books? Are you looking at them? Yeah, your books are really nice. Yeah, very ready to go. Your books are really helpful. Use them. Read them. Study them. Okay. Number 7. A polynomial function is written in blank form when its terms are written in descending order of the exponents from left to right. I think y'all know that one, don't you? I know the example we did today, example 5, put them in that. I can't remember where that was said in the text. Something you knew from way back. But anyway, that's called standard form. I can't find it in the book, but I know it's there on example 5. Number 8. The blank blank theorem states that if f is a polynomial function such that f of a is not equal to f of b, then in the interval a to b, f takes on every value between. Okay, I hope that was saying intermediate value theorem, wasn't it? Yeah, that's what I thought it said. Okay, so homework exercises here include, I would do all 9 through 14. Okay, now only the answers are given for 9, the odds, but do them all. They're easy enough to do. Okay, they're just matching. Then do either 15 or 17. They're both at Calc Chat. 17's at Calc View. Any of the odds 19 to 27, they're all at Calc Chat. 21's at Calc View. Do either 29 or 31. They're both at Calc Chat. 33 through 47, they're all at Calc Chat. 43's at Calc View. Then they say using technology, do either 49 or 51. If you got a graphing calculator, you can do it, but I bet you can do it without one. But those should be at Calc Chat. 53 to 61, they're all at Calc Chat. 59's at Calc View. 63 to 69, they're all at Calc Chat. 67's at Calc View. 71 through 83, they're all at Calc Chat. 73's at Calc View. 85 or 87, both at Calc Chat. 89 or 91, both at Calc Chat. 89's at Calc View. And then do any of the odds 93 through 97. They're all at Calc Chat. They should be. 99 and 101 are both true false. They should be at Calc Chat. 103 and 105, if you want to try those, you can do it. You can think about doing 107 if you'd like. All right. Now, y'all do know the good news, bad news situation, don't you? The good news is next week is spring break week. The bad news is we won't have any classes. Sorry about that. Get over it. Okay. Now, what but on Tuesday of the following week, that will be the 31st, I believe, we'll be meeting again right here, same time, same station. Okay? I'll get. No, it'll be a different code, and I'll put the code out there sometime between 8 and 8:30. I'll put the code out there, and then you use that code to come back. Every time I end the session, I have to start with a new code. So,
Can you cut the grayscale off?
Can I do what?
Cut the grayscale on Blackboard. Like it shows the things you put in, but it don't show the average.
Okay. I'm going to try to do that tomorrow. I've got class all day today. I've got class starting in 15 minutes, less than 15 minutes now. And then I have another class 15 minutes after that one. Then another class 30 minutes after that one. And that class is supposed to go till 5:45, but I think we'll finish a little early today. So I may have time to do it this evening, but the first thing I'm going to do is try to mail stuff to people, email and stuff like that, and then I'll try to get the grades done too. I've got everything graded. I just haven't had time to put everything in Blackboard. Now, if I was not sure that you finished your test, I'm going to be mailing that to you if I can get your address. So if you want to, if you did not finish your first test and you want to email me your best mailing address, I can't email you those tests because there's too much papers there. So I'm going to mail them in the mail, and I hope to put them in the mail tomorrow. So if you'll send me your mailing address, I will do that. Otherwise, I'll get it from the school. I hope the school is right. I know what you send me will be right. But I'm going to do that for everybody who did not finish the test. And I'll only grade the things. I've already graded the things that you worked on. It'll only be the ones that you left blank. So get them back to me as soon as you can. Those, when you send them back to me, you can either mail them back to me or you can scan it and send it by email. Okay? It's just that I don't have we do have a scanner at home, but we haven't got it set up yet. My wife was going to have to take those in and scan them all at work, and she didn't even want to go to work and be there that long. So she's got to go in tomorrow, but she's going to try not to be there any longer than necessary. So I'll try to get you as much things as I can. If you don't have a grade there yet, it's because I wasn't sure you were finished. So you should be getting something in the mail from me if I have your right address. Okay? What's that? One more time. Say it again.
When you finish grading everybody's test, can you let us see what we missed?
Yes. Well, I'll have to mail them back to you then. So, yes, I'll try to do that. But the thing is, that's a lot of mailing. Right now, I've got, I think, 16 to mail now. And I've got to just get their address first. If we do go back to campus, if y'all go back, I will try to get them there and have someone distribute them to you if I can't go back. The dean said she did not want me back on campus because of my health situation. So even if y'all go back, this class may still be online like this, but I'll try to get them to campus and get someone to distribute them, like Dr. Thomas. Like she gave them to you, she'll be able to redistribute. But she's only there on Bessemer on Tuesday and Thursday. But as I said earlier, maybe you weren't here, I don't think we're coming back the 2 weeks after spring break. That's what they keep saying. University of Alabama and UAB have just said, nope, we're going to be online for the rest of the term. They're not even going to do graduations. They're going to do virtual graduations. They're not bringing groups together. The pandemic is not going to be through in 2 weeks. It's just not going to happen. So I think we'll still be doing this. But if you do want those back, I'll have to mail them to you. I can't just scan them, but I can put your grades on Blackboard. But but if you do want it, just let me know and I'll mail them back to you. But get them to me first. So I'm going to be mailing these out tomorrow. Hopefully, maybe even later today, but if I can get them done. But I don't think I'll have time. Yeah, it's going to be 6 o'clock before I finish today. So it'll be tomorrow sometime. All right. Any other questions? Was that a yes?
If you wanted to, like send like the grades without having to mail them, you could just take a picture of them and email them like that.
Okay, take a picture of it and do what?
Take a picture and email it to them.
And put it on an email? Is that what you said?
Mm-hmm.
Okay. If that's okay with you, I can do that.
You can do mine like that because my grade already is for me.
Okay. Okay. I can do that. My wife took pictures. We were going to try to take pictures of the test and send them to you, but I was afraid that would be too hard to read for you to be finishing. But I'll mail those to you. But then when I finish grading them, I'll take pictures and send you that. You want every page or just the front page? I'll do 2 pages. Okay. Do you need your scratch work and your graph?
No.
Or, okay, just the 2 pages. Okay, we'll take pictures and send those back to you. But what you'll get in the mail now is the unfinished test. And those people who haven't started the test, what I'll be doing is emailing you a either a PDF form or a Word document, probably a PDF. Okay? My wife's going to scan those. Those are easy. I'll just send everybody. But I think it's only 3 people who didn't get a test to begin with. I'll be scanning those and sending them that in an email. I'm sorry things are slow right now, but I'm setting up an office at home, and my wife's here working at home too, and she's in the office now. I'm up in a bedroom, so we're just having to share the computer resources. I have my laptop, but the printer and scanner and all that's down in the office. Okay? Well, y'all have a good break, spring break, but that means be a safe spring break. You don't want to have to self-quarantine again, okay? So try to stay tight. You know, don't get around anyone who could be. Karen's having all our food delivered by ship. She doesn't want me going out anywhere. So we'll have to manage. So y'all have a good break, okay?
Okay.
All right, bye-bye. Any other questions? All right. Take care. Goodness gracious.